Hello, I'm Dale Hyde, the Client Solutions Advisor here at Frontier Technology. Welcome to this in a nutshell video. Previous videos in this series have looked at the basics of public and private cloud, the differences between infrastructure, platform and software as a service, and explored the implications of cloud security. Today we're going to look at serverless computing, which I like to think is the steps beyond the infrastructure, platform, software as a service discussion. You might have heard of serverless computing, but what is it? For many people, it's a bit of a misnomer, as there are indeed servers deployed to provide these services, but you won't see them, not even logically, as there are several layers beneath the visible architecture. I think the easiest way to understand this is to start by considering what serverless computing is not. If we think of a regular cloud infrastructure running virtual machines, whilst the machine is provisioned, you will be charged for it, even if it's idle. You could turn off the machine to reduce cost, but that isn't always convenient, and you still have to pay to store the VM. Whereas in the serverless computing world, you only pay whilst the code is actually executing, usually in response to an event triggering the code. Think of this as a way of deploying smaller on-demand applications that are responsive to events, and that you don't have to concern yourself with the underlying resources such as servers, hence the name. Typically, an application would comprise many of these smaller on-demand elements. So because you don't pay for this service while it's not actually running, in some scenarios this can be financially attractive. Other strengths include simpler scaling and developer deployment, as the service provider takes responsibility for all of the underlying resource. However, there are downsides as well, so as with everything with IT, there's a balance to be considered. The first of these is the potential for application latency. Typically, the service provider will spin down the serverless code when it's not being used, which means it has to be fired up again when it's called upon, though some service providers now allow you to pay a little more to reduce its impact. A second factor is developing the application architecture. You'll likely need specific skills to incorporate serverless computing, and these are not widely available today. Also, it's likely that applications need to be modified or even rewritten to adopt the serverless approach. There's also a question mark around portability, as many serverless technologies are tied to the cloud platform you're deploying in. In some respects, security can be regarded as being stronger than with VMs, as the service provider has the responsibility of taking care of operating system vulnerabilities. But on the flip side, the potential total attack surface can be much larger, as there are many more components in the application, each of which could be an entry point. Examples of serverless computing include Azure Functions, and then Google and IBM have the similarly named Cloud Functions, and AWS offers Lambda. All of these lend themselves well, I think, to digital transformation programs, where large-scale re-architecting of applications and infrastructure can be part of a bigger picture. Whether they have a role to play today for smaller businesses is more difficult to determine. On the one hand, if you're developing a startup, online business that needs to react swiftly to demand, then serverless could be a great fit. On the other, a typical business happily running on a number of VMs would need to find some compelling use cases to justify the changes needed. So there we have it, an in a nutshell summary of serverless computing. If you found it useful, please subscribe and give us a like. Or if you'd like some help with cloud migration or management, please get in touch. Thanks for watching, and goodbye.